I will try to post the recording on Canvas. This is my first time TAing, so I'll probably have to do a little searching to figure out how to do that, but I will post it as soon as it's available. One more thing. So like in the lecture, I have Mark has somebody, one of us, monitoring the chat. I do not have that. So like I said, there are only 19 of you. So if I'm sharing the screen, it's going to be very hard. It's going to be very easy for me to miss that somebody has put a message in chat. Please feel free to unmute yourself and just ask me directly. It's a much smaller group. You should have no problem getting through today. All right, so let's look at a piece of function notation. So if we look at this right here, read f of 3. So there's a function. We don't know what it does, but we don't need to know right now. Its name is f. F of 3 is the value of the dependent variable. So usually we think of the dependent variable as having the value y, typically. So f of 3 is the value of the dependent variable when the independent variable has a value of 3. And I think what you've been doing a lot with Mark, and you've probably been seeing function notation for many, many math classes, but we're solidifying things because as you've seen, what we do in 271 in this class is a lot more conceptually emphasized than what you might be used to. So in general, functions model the relationship between two, could be more than two, but at least two interrelated quantities.
I have a question.
Go ahead.
Sorry to interrupt you. So you mentioned f of 3 is the value of the dependent variable.
Mm-hmm.
So most of the times when we're discussing independent or dependent variable, I feel like we're referring to like x and y, or how, because x as a quantity keeps changing over time,
Mm-hmm.
that's probably the independent variable, right? So in this case, are we saying f of 3, in a way, 3 can be, if replaced by x, x is still the independent variable?
Absolutely. So
okay, awesome.
One thing, so that's a really good point, and I want to bring up for this example here. I did not tell you what the independent variable was. I just gave you f of 3.
Right.
So the independent variable could be time, it could be length, it could be any number of things. In general, we just think of it as x. So one piece of terminology I've seen in the textbooks class, I don't know if it's come up in lecture yet, I don't think so, but the independent variable and the determined variable. So basically, which variable do you have control over? Usually the independent variable. So if we're talking about, if we put a context behind it, maybe it'll be a little easier to think about.
Right.
Usually time is independent. We have, time just marches forward. We have direct visibility to time, but whatever time is affecting, so population or the amount of money in a bank account or whatever you're looking at, that is determined by how much time has gone on. It depends on time.
Thank you.
Thank you. So in general, functions model the relationship between two interrelated quantities, and this is a relationship that's a lot easier to explore when you assign those quantities, when you know what those quantities are. When you're talking about x and y, it's not terribly meaningful. It's not terribly obvious what you're doing yet. So the context will dictate what the quantities are and how they're related. So like in this case here, I just said f of 3. I've given you no reference to some kind of situation that we're looking at, as opposed to right now. So let's look at this example here. So the number of calories that you burn is a function of the number of minutes that you exercise. We'll call that function f. So knowing that that is the situation I'm putting behind this, we want to interpret the meaning of the following. So I have f of 95, f of c equals 140, and f of z minus f of 40. So what I like to do right now, I'm just going to pause for a couple of minutes, and when I come back, I want some answers for possible interpretations of these things. So right now I have 9:11. I'm going to come back at 9:13, and so work on these on your own for a couple minutes. See what you can come up with. One thing I want to remind you, first of all, is the penalty for being wrong on these kind of things in recitation is absolutely nothing. So this time is first and foremost meant for you guys to practice and refine the things we're learning. Very low stakes right now. Just trying to get good at these things for when the stakes are higher. So I'll be back in a couple of minutes to get your thoughts on these three. All right, does anybody have anything they would like to contribute for F of 95?
I said the F of 95 was the number of calories burned in 95 minutes of exercise.
Okay. Anybody else have anything different? So was that Isabel?
Yes, yeah.
So we have the number of calories you burn after exercising for 95 minutes. How do we feel about that?
Good.
Good. So the number of calories you burn when exercising for 95 minutes. Good. How about the next one? F of C equals 140.
Oh, sorry. Go ahead.
Go ahead, Matthew.
Yeah, C is the number of minutes that it takes to burn 140 calories.
Okay. So you exercise for C minutes and burn 140 calories. We feel like that's pretty close or maybe even identical to what Matthew said?
Yeah.
Yeah, it's fine. I mean, so we're looking for, when we're answering in plain English, there's obviously a lot of ways to communicate what we're doing. And finally, F of Z minus F of 40.
The change in the amount of calories that you burn between 40 minutes of exercise and Z minutes of exercise.
Okay, the change in the number of calories you burn between 40 minutes and Z minutes of exercise. Did anybody state that? So I'll tell you right now, I believe what Zach said is really, Zachary or Zach, I'm sorry.
Zach.
Zach, okay, I believe what Zach said is really good. Did anybody phrase that differently at all?
The variation instead of the change, but I think that's the same thing.
Yeah, so I mean, like I said, there's a lot of different ways to interpret this, and I don't remember exactly what I said. Yeah, the change in calories burned from 40 minutes of exercise to Z minutes of exercise. That may or may not be exactly what you said, Zach. So moving on, let's look at a different context here. And this one we're going to spend quite a bit on. So let T be the time in seconds since a race car began moving after a pit stop, and let D be the distance in feet traveled by the car since it first started moving. So which of these above quantities is independent and which is dependent? So what do we think? So we have two quantities here. One is T for time in seconds and one is D for distance in feet. Which one of these do we think is independent?
Time.
Time? We agree with that?
Yeah.
Right. Which by default would make the distance dependent. And that's absolutely correct. So like I said, so think about, I think for me, the terms independent and dependent variables have always been a little cryptic. Just think about, which one do you have no control over? We really don't have any control over time in most instances. Time just passes. What we might have some control over is, the way we're driving the car, the way we're braking and accelerating, things like that. That one depends on time. So now let's go the opposite direction. I'm going to give you a few descriptions in English, and I want the function notation. So we're going to use a function called W. So that function w represents the distance d at any number of seconds t. So I have 4 different scenarios here. The distance driven the first 9 seconds, distance traveled from t equals 2 to t equals 5 seconds, and so on. Again, I'm going to give you a couple minutes here. When I come back, I would like some more volunteers for the function notations that would give these ideas. So I have 9:17. I'll come back to you at, let's say, 9:19. All right, let's go for it. So the distance driven in the first 9 seconds. Who wants to give me a piece of function notation for that?
I have W of 9.
W of 9. I like it. So, yeah, W of 9, and one thing I forgot to animate before, we're letting D equals W of T. So D stands for the independent variable, or sorry, D stands for the dependent variable, distance. T stands for the independent variable, time in seconds, and W is the function that translates or maps the independent variable to the dependent variable. How about the distance traveled from t equals 2 to t equals 5 seconds?
W of 5 minus W of 2.
W of 5 minus W of 2. Okay, and I got that in the chat as well. Can someone tell me why it would not be W of 2 minus W of 5?
Because you always want to take your final value minus your initial value, and since 2 is the starting value and 5 seconds is the final value.
Good. So yeah, we want to go to represent the change in something. You definitely, yeah, you want subtract the initial from the final. So yes, W of 5 minus W of 2. Next, the car's change in distance in its third 4-second interval. So I have in the chat, I have 3 times W of 4. How do we feel about that?
I have W of 16 minus W of 12.
Okay, I also hear W of 16 minus W of 12. So I've got a couple answers submitted so far. One is so I've heard a couple of things here. 3 times W of 4. And I'm sorry, what was the last one? Was it W of 16 minus W of 12?
Yeah.
Okay. How do we feel about either one of those two, or do we think it could be something different?
So wouldn't W of 16 minus W of 12 be possibly the timestamp from 16 seconds beginning. I mean, that should be a little more different than 3 times W of 4, right?
Yeah, so these two things are definitely different from each other. So let's look at the first one first. 3 times W of 4, let's just break it down. What would W of 4 give you?
Distance traveled after 4 seconds.
So the distance traveled after 4 seconds, and then we're tripling that. So I don't think that quite gives us what we're looking for in that third 4-second interval. I will tell you that W of 16 minus W of 12 is a lot closer, but I still think we need to edit that a little bit. So let's think about this. The first 4-second interval, what would the beginning and ending times be for that first 4-second interval?
0 and 4.
0 and 4. And how about the second?
4 and 8.
4 and 8. So the third one would be what?
8 and 12.
8 and 12. So what should this expression be here then?
W of 12 minus W of 8.
W of 12 minus W of 8. So yeah, I think we got a little bit tripped up on where to start that interval, but really good work there. And the last one, the change in distance over any 7-second time interval beginning where t equals x. So one thing I want to highlight here, I'm saying the change in distance. So what should that automatically tell you about what your expression needs to look like?
A subtraction.
Yeah, subtraction. I'm taking the difference between two things. So now let's figure out what the difference is, what those two ideas are.
So W of x plus 7 minus W of x.
So I'm hearing W of x plus 7 minus W of x. Does anybody else have anything a little different? I think we're right on the money there. So I don't know what x is, and it doesn't matter. I just want to measure 7 seconds beyond that, and then take that difference. Any questions so far, everyone, before I move to my next slide?
Sorry, just one question.
Sure.
So you said over any 7-second time interval, does that mean that because X is when the time is beginning, we're just gonna add it to the 7 seconds?
Exactly. So it does not matter what x is, or maybe I want x to be different all the time.
Uh-huh.
Maybe in some instant I would like to know how far I travel in the first 7 seconds.
Right.
Maybe I want to know how far I travel, after I've given myself 10 seconds to drive.
Okay.
So the constant there is the 7 seconds. The 7 seconds long the interval is.
Mhm.
What I would like to keep variable is when that starts.
Okay.
Good question, though. Anybody else before we move forward? Okay. And then we're going to go switch gears again. So I'm giving you some function notation. Give me some interpretations of what I'm looking for here. Do you all think the 2 minutes is a little bit too long, or is that pretty okay?
I think the 2 minutes is good.
Okay, we'll stick with it.
Awesome.
All right, so take a look at these, and then I'll come back to you in a couple minutes.
Stephen, I have a question.
Go ahead, Zach.
So, was there a unit? Were there units given for distance?
Yes, I believe there were, did I not? I believe they're in feet.
Cool.
If I left that off, I apologize, but I meant to have that in feet. It's a really good question, though. I mean, when you're interpreting quantities, you should be specific and give the units you're measuring in as well. All right. Let's get after it. How about 2W of A? What does that mean?
Is it 2 times the distance traveled in A seconds?
Yes, so twice the distance traveled in A seconds. And what are we measuring that in?
Feet.
Feet. Yeah, so twice the distance traveled by the car after A seconds. And I just told you to be specific, and then I was not, so that's my fault. How about W of C minus W of 8?
Change in distance from t equals to c to t equals to 8.
Okay, so change in distance from T equals C to T equals 8. How do we feel about that, everyone?
Actually, wait, that might be wrong.
Why might that be wrong?
Because technically, if we're subtracting of c minus w of 8, that probably means that it's from t equals to 8 to t equals to c. Sorry, I messed that up.
No, you're good, and I'm actually kind of glad that happened. So one of the things that it's very easy to get tripped up on in these is which quantity you want to subtract from the other. But I think you found it and corrected it very well. So the distance traveled between T equals 8 and T equals 2 seconds. If C equals, for example, 3, what should I expect to get back from this quantity?
A negative change.
Something negative, right? You know, distance, the way that, at least the definition that I prefer to use is, you know, distance is not something that can never decrease. Next one, W of 7.5 minus 9. And I got on chat from Cassandra. Please tell me if I pronounce your name incorrectly. 9 feet less than the distance traveled in 7.5 seconds. I like it. So 9 feet less than the distance traveled after 7.5 seconds. And finally, W of 3 plus H minus W of 3. And Michelle Wen says, change in distance over any time interval beginning at 3 seconds. I really like Michelle's answer, but I think it's missing one key idea for me.
Time interval H.
Right, the time. So it's not any time interval. It has to be a time interval that's how long? So it has to be H seconds long. So distance traveled in the H seconds after time equals 3 seconds. Any questions for me before I move on to the next slide? All right, let's keep going. And I believe these are our last two. So these are a little trickier, perhaps, than what you've seen so far. So one option I didn't give you when I asked if 2 minutes was, I asked if 2 minutes was about right or too short or too long. Does anybody think you need a little more time than that? Right. I'm not hearing any protest. I'll stick with 2 minutes. I believe the first one should come a little more naturally to you than that second one. That's a little trickier. But I'll check back with you in a couple of minutes. All right, that's 2 minutes. Before I ask you all for answers, one thing I want to encourage is that I wish I would have thought of at the beginning of class here. Just because I'm staying quiet for 2 minutes doesn't mean you need to be. So I think a really important way to solidify a lot of these concepts is to not only be able to convince yourselves of it, but be able to explain it to somebody else. So if while I'm kind of hanging back for 2 minutes, you all want to discuss this with each other, either over chat or verbally, I would love to hear that. So if you're good to work on these on your own, that's fine with me. But if you would be better served asking questions or answering questions, please don't feel like you have to stay quiet. Like I said, I really don't feel like I can overstress this. This time is for you guys to solidify and practice things. So please ask all the questions you want.
I have a question for the second part. It says that it's all over 0.5. So do we say something around like the change is, how do we put it in words, I guess?
Oh, so
Because-
that's a couple of good questions there. So you are seeing that there's some kind of change happening there.
Right.
The other broader point I guess I want to make is there is no one way to say, to say what I'm looking for. There are key ideas that are at play there, but I'm not looking for, the one magical way to phrase
Okay.
it. But I do think that you locked in on a very crucial idea to that second one.
Going off of what she said, does it mean like, do you want more specific answers rather than just the change divided by 0.5?
No, I think that's actually, I think there's a lot of good questions, but let's handle the first one first. I'm not getting a lot of questions about that, so maybe that's because we feel okay about that first one. So W of t plus 10 minus W of t, how do we feel? Does anybody have a good answer, interpretation for the first one?
I have
I
the
Go ahead.
I have the change in distance on a 10-second interval starting at t.
The change in distance over a 10-second interval beginning with t. So distance traveled in the 10-second interval following t seconds. So definitely don't say it as clumsy as I did, but I think that that answer was very good, right on the money. So this next one, we have a obviously have a couple things we have to talk about. So I have w of x plus 0.5 minus w of x over 0.5. So let's just remind me, I think I have a couple answers in chat. Oh, no spoilers. Any interpretations for this one?
I said, it's kind of a mouthful. Twice the distance of the change in distance in half a second interval beginning at x seconds.
Okay, so the half-second interval. So I heard a lot of key ideas there. So there's an interval that's half a second long. It begins at x seconds. Did you say you were twice the distance?
Yeah. So basically twice the quantity of that change in distance.
Okay, so because we're dividing by 0.5. Okay,
Yeah.
so twice that difference.
Correct.
So I'll tell you right now, that's mathematically and numerically, that will be correct. So if I find the distance over that interval, over that half-second interval that starts at x, I'm going to double it because I'm dividing by 0.5. So let me ask this. Let's go a little deeper. Why would I divide this by 0.5? What am I doing?
Are you dividing it by 0.5 because 0.5 is the time interval?
Yes. So divided by the time interval. So yeah, there's no coincidence that the interval is half a second long and I'm dividing by 0.5. So what am I looking for there by dividing by that time of 0.5? And I think I saw it in the chat, but I'm having trouble accessing it right now. Did someone say velocity? Or did I imagine that?
Yeah, someone said it.
Okay. So how do we calculate velocity usually?
Distance over time.
Yeah, distance over time. So look at what I have in the numerator here. I hope y'all can see my cursor. Can you?
Yeah, we can.
Yeah.
Okay, good. So whoever responded first was right on the money on what the interval is. So the interval is half a second long. It starts at time equals x, and I'm taking a difference. So my numerator here is really a change in distance. My denominator is really a change in time. So yes, what I'm looking for is a speed. So like
I
I
have
said,
a question real fast. Sorry to interrupt, but is velocity like synonymous with rate at that point, or should we just refer to it as velocity or speed?
so I'll say this, if you say rate, I mean, a rate is something more general. A speed or a velocity is a type of rate. You would certainly not be wrong if you said rate of change.
Okay, cool. Thank you.
So one thing I do want to point out, I mean, I know we're not in a physics class, but speed is more correct than velocity, though I don't want to get too hung up on that. But like I said, there are many, many ways to state these ideas. I think it is more correct to involve something with a rate of change, because that's really why I'm dividing by 0.5 here. I'm looking for an average speed. So over that half-second interval that begins with t equals x, I'm looking for that average speed over that separation in time. But I really like all the questions with that one. I think you guys, you all handled that was a pretty tricky one, and I heard a lot of good questions and a lot of good discussion. Any more questions before we wrap up here? Okay, so we have about 8 minutes left, and I know you have something due for GC tomorrow at 9 a.m. Does anybody have any questions they would like to get answered before we adjourn today?
Is this what Mark means by this is not going to be the standard math class where you're just cranking out equations and this is how we're going to have to apply it?
This is a small part of it. The larger part of why Mark says that is when I think of a traditional Calculus 1 course, you know, when you get into derivatives, for example, it's like, all right, here's the definition of a derivative. Here's where the power rule comes from. Here's how to find the slope of a tangent line. Here's how to find the equation of a tangent line. We'll solve some related rates problems. But it seems like what's very divorced from that is what you're actually doing. So it's more about how do I find a derivative and what do I do with it than why is a derivative powerful or why is an integral powerful? Why would I do it? What does it really buy me? What does it really help me interpret? So yeah, GC is one key difference, but the larger difference there is that rather than focusing on techniques and process and step by step, we're focused on meaning and concepts.
So like meaning and concepts as in real life, or are we going to be learning more in depth like why a certain derivative is the derivative of something rather than just secondhand nature, just knowing that it's going to be that?
The answer to that or question is yes, essentially. Basically, you're going to be, because we'll be getting deeper into why derivatives work a certain way and a more general idea as to how you can use them. You should be getting a deeper understanding of both, and I believe that you will be. One thing I want to answer, I saw in the chat, if somebody asked if you have the GC homework done, can you leave ahead of time? Like I said, at the end of every recitation session, you will have either something to turn in or a quiz to complete. Don't leave before you find out what that is. We only have a few minutes left, so let me take a couple more questions, then I'll open that quiz for you all.
I was just wondering, could you post this like slideshow to the like where we could print it and stuff and keep it for notes?
Absolutely. So, like I said, this is my first time TAing in class, and it's my first time using Canvas, not as a student. So I'll have to do some digging as to how and where I can post these, but as soon as they're available, I will let you all know. But
Awesome, thank
I will
you.
definitely post the slides, and I will definitely post this video.
Is there going to be like a separate, because I only have the MAT 271 class. I don't have like a separate recitation in my Canvas.
Right. So your grade will all be, basically your grade all goes to the lecture. I believe Math 271 is a 4-credit course, right?
Yeah.
Right. You're spending 3 hours in the lecture and 1 hour here.
Okay.
But as far as like how your grade gets reported, it's all going to show up like under Mark's lecture class.
Gotcha. Okay.
Yep.
Thank you.
Thank you.
Is the function notation worksheet the one that we need to work on?
That one should have been due. Is it okay if I stop sharing right now?
Yep.
It sounds like you're asking about something on Canvas, right?
Yeah.
All right, let me go take a look. When is the worksheet you're asking about? When is that one due?
So there's a
It's
function
25th
notation worksheet.
today.
Yeah. It opens today by 3 p.m. or so, but I guess I'm confused because we just worked on function notation. So
Yeah.
do we submit that for recitation?
Not for recitation, because that one's going to become that. He says he's going to open that up at 3 p.m. Right?
Right. Sorry.
Yeah. So yeah, he'll open that up at 3 p.m. and yeah, I have a due date of Friday. So yeah, just
Thank you.
yep, no problem. Any other questions? All right. Thank you everyone for a good first day. I really liked all the questions, all the discussion. And I think that like I said, I mean, I would love it if there was even more talking from your end. Just because I'm quiet doesn't mean you have to be. So we do have a quiz that I'm going to open up for you right now. So you should see it published on Canvas right now. I'm going to stay in the room for a little while to make sure that everything is working the way that I think it should be. You will see that there's a passcode for the quiz. That passcode is chlorine. It's in chat as well if you want to just copy and paste it.
Is this the R01 function?
O1. Yep.
Thank you.
Don't be alarmed by the screaming of children or barking of dogs. That's just going to happen from time to time. Can someone confirm that they were able to get into it or?
Yes.
All right,
Yeah.
cool. I don't know if it makes this clear, but you have 10 minutes to finish that from when you open it. But if you're looking at the quiz, then yeah, we are done for the day. I'm going to stop recording. I will hang out in the room for another 5 to 10 minutes just in case anybody has any questions. But thank you all, and I'll see you either in lecture or next Tuesday.
Go Dodgers.
Thank you.
Negative 1,000 points.
Have a good one.
Take care.